26 is asking if we can conclude that the quadrilateral at the right is a parallelogram. My suggestion is to begin by looking at some of the triangles that are inside this potential parallelogram and see if you can prove that those are congruent. So I'm seeing that there are parallel lines here. So let's take a look at this transversal right here. If this transversal, we could use this angle right here and this angle right here. We could say that those are congruent by alternate interior angles. I'm just going to call that angle 1 and angle 2. So I'm going to say that angle 1 is congruent to angle 2 by alternate interior angles. We also know, we've already been given that this segment is congruent to this segment, and we could finish it out by saying that, I'm going to call this angle 3 and this angle 4. We can say angle 3 is congruent to angle 4 by vertical angles. So we can pretty quickly see that those two kind of sideways triangles are congruent to one another by angle, angle, side, which means that these diagonals are congruent to one another, where and that means that this diagonal here is bisected. And if diagonals, both diagonals in a quadrilateral are bisected, then we know it's a parallelogram. So can it be concluded? Yes. The diagonals bisect each other. Now, are there other ways that you could have proved that this was a parallelogram? There's a lot of ways you could have proved it. But this is just the one that I chose because I think it was the most direct route.